Alright everybody, I'd like to welcome you to my shop. In this series of videos, we're going to take you start to finish from the beginning of the knife to the end of the knife. And we have a lot of cool things planned. Doing, of course this is the forging video. We're going to do handle grinding. We're going to do some casting for the guard. And so we got some cool things planned. But here I'm lighting my ribbon burner forge. If you've never used one, it can be a little bit tricky to light, but once you get used to it, it's not too bad. So coming up, I used to not do this, but I'm a big advocate of it now, is just to kind of rough sketch out the direction you want to go in your forging. Just get some basic dimensions, so that you don't get yourself stuck between a rock and a hard place later on, so that you know that you have enough material where you need it and gives you something to go off of. So the stock we're using is 5160. It's a 1/4 inch thick, about 1 3/4 wide. So we're just going to get it in the forge. I have the forge set to run at 2000 degrees. Once it's up to temperature, we're going to pull it out, and we're going to go straight to the vise. And what I do is I stick it in the vise and I get the corners knocked down. It's the most important first step to do, because if you don't take care of the corners, then those are gonna fold over and create like this little fish lip, and you'll fight them through the whole process of forging. A lot of people do it on the anvil, or some people hot cut them off or grind them off. You know, I paid for every bit of this material, so might as well just keep it. We're going to go straight over to the anvil now. So continue working those corners. But as you work those corners, they're going to upset in the width, in the thickness I should say. So you want to forge that down as well at the same time. Because if you don't, they're going to fold over if you let them get too thick, and you're going to create, like a cold shut, which is a problem. Alright, so next, I work on the point, but I forge it down just one side, so that I have a nice taper and the one edge pretty much stays straight. So just keep working that. It's got a little bit of a curve into it because it's a Bowie style. That curve will play a major factor coming up later on, which you'll see. Here I'm sketching out some basic dimensions on the anvil. This will help me in the next step where I lay out where I'm going to start the tang. It's important to know where your tang starts and to keep track of it at all times. So here I'm setting these little marks right in the stock so that I know that from there to the point there's no tang there. It's all from those marks back. So this might be a little bit of a different technique than other people. When I draw out the tang on this, I pretty much only forge one side. I tilt the blade forward a little bit, and I set that notch that I previously made in the corner of the anvil, and then work the tang back. And what that's causing is I've already got that little notch in there, and as I forge the tang down, it's causing the entire blade to shift down and creates a step. And that becomes handy in this style of knife, because a Bowie knife, you don't really want that much of the spine above the edge of the handle. So a lot of the blade is below. So your tang is going to be offset up towards the spine and not dead center. So by just forging one side of the tang out, but keeping that index mark at the corner of the anvil, it causes the blade to push forward and down and creates a little step. Now you kind of have to be careful and just kind of work it as you go, but it works pretty good. So right here I'm using, this is one of my favorite hammers. It's, I don't know, a 2.5 pound ball peen that I've converted into a rounding hammer. And I'm just working that section and moving as much material as I can. But remember, as you forge that area down, it's going to thicken. And as it thickens, you want to make sure to draw that out and not allow it to get super thick, because it'll create kind of like a wave shape. It'll curl out, and if you don't catch it in time, when you go to forge it back down, it's going to fold over on itself, and then you might as well just grind it off because it's serving no purpose besides being a stress riser. Yep, just keep working it. Once you get your thickness where you want, just keep thinning it out because it's obviously thickened up quite a bit. The other thing that's nice is by having the notches for where the tang starts, if the tang starts to curve, which it will, you can flip it over, set that notch in the anvil, and then forge the other side, which straightens out the tang. And so it's nice having those notches because it gives you a place to index, which is really important. You always need to know where you are at. So here's a little trick for some people that have a hard time establishing the shoulders of their tang. I use the vise again. I just heat it up. Since I've already established those on the anvil, I can come in with the vise and just squeeze it down. So you just give it a good bit of pressure, and then I just give it a couple whacks with a good sized dead blow hammer. It seems to set them in nice. And my vise is a little wonky. I don't know why. When I tighten it, the jaw slides to the right a little bit, but it works good for what I need it to do. But that's a little trick that allows you to establish a nice square shoulder on your tang without having to grind it. I mean, we still grind it. Well, we actually mill it, but you'll see that later. So just keep working the tang out, because this is where a lot of material gets wasted if you don't forge it. If you just leave it thick, you lose quite a bit of material if you just grind it away. So might as well save it. Towards this part, you'll notice that I forge down to a much lower temperature. So here we are forging out the bevels. Now you notice what you thought looked like the edge is actually the spine. But because we created that curve, as we draw out the edge bevels, it's going to cause that curve to sweep up. So that gives us a straight clip style point, and then gives us a nice sweeping belly to the blade. So it kind of just takes some practice and experience to figure out how the material moves, but once you get a hammer in your hand and you start going, it's pretty easy to kind of figure out where things go. Being that I use a rounding hammer, it's a lot more aggressive in how it moves material. But it moves material uniformly in all directions because it's basically the base of the hammer is a ball shape, kind of. So a trick to getting it to go where you want it is to kind of push the hammer as you forge in the direction you want the metal to go. So with the edge facing me, you can kind of see how I'm kind of pulling the hammer towards me, and when the edge is away from me, I push the hammer away. And it kind of helps move that material in the direction I want. As you're forging out the edge bevels, of course, the edge will become kind of bumpy. And so stick it up on the spine, just tap those bumps down, and then just go back and work it out. Here I had a little bit of wonky in the spine, and so by heating it and just tapping it, the spine on the base of the anvil, it solves some of that and gets a little bit more curved back into the tang. Like I said before, you notice I'm working the steel to a lower temperature than normal. With 5160 it's not a problem, as long as you don't do anything real major. Some mild straightening and things like that's not too bad. But if you're really going after it, when it's in a black heat like this, then you can have problems where you're going to crack the material. The old saying is that there is a special place reserved in hell for people that work cold steel. So just keep working the edge. I had to pull this out a little bit more just because I wanted as much width as possible. The customer wanted a really nice wide fat blade. So it's kind of a balance between making sure you have enough material left that when you grind it, you're not having to compensate your edge one way or the other because it's too thin and you didn't leave enough material to compensate anything that's not perfectly centered. The old saying is forge thick, grind thin, which holds a lot of weight. But I also think that you should be skilled enough to put material where you want it so that you don't have to grind too much off, because that's just a waste. Not that steel is very expensive, but if you're going to do it, you might as well do it. So as you're forging, just keep an eye on everything to make sure things don't go wonky on you, because it will. You're forging one end, tang will get crooked or twisted or warped because, you know, it's how things happen. So here is the very butt of the tang. I do the same thing, come in, square it up. This will leave me a little bit more material on the bar that I chop off for next time. So I just come in, anything that's a little bumpy, anything that's a little funky, come in, just kind of use the vise as a press almost. It works really well when the steel's up to temperature. So right here, I've clamped it up against the shoulders, and then I just pull the bar towards me a little bit, and it gives that little curve. Give it an eyeball, make sure everything looks good, everything looks straight. So we'll just move on to the hot cut. It was kind of hard because the sun was setting and shining right on the hot cut, so I couldn't quite see what the temperature was. It was a little cold for what I needed, but it worked out okay. So the camera actually overheated right here and shut off, and I didn't realize the camera had stopped. I did a little bit more right at the tang. I didn't reheat, I just kind of tweaked it a little bit. But that's the end of the forging video. I'd like to thank you guys for watching, and like I said, we got some really cool stuff coming up, especially some casting of some bronze, some silicon bronze that I make myself. So I'll walk you through that. I'll show you how I alloy up the copper. I'll also show you how I smelted the copper, not smelted, melted, smelted, whatever it is. I'm new to the smelting aspect of things, so thanks for watching, and we'll see you next time.